Good morning, ladies and gentlemen. Before I start, I just want to say thank you to the organisers of the conference for giving me the opportunity to speak to you. Actually, I was amazed. I was talking with people at dinner last night how well attended this event is. I mean, this is a full room, and it's always nice for somebody like me who works in the environmental area to come to different places and hear the nature and the tenor of the debate. And I congratulate you on yesterday, which was a fascinating day, and really gave me some new perspectives. So before I start my speech, I'll maybe give you a little bit of background about NATS, the UK air traffic service provider. We control actually slightly less traffic than our colleagues at DFS, about 2.1 million flights a year. Back in 2008, we became the first air traffic service organisation in the world to have environmental targets. We set a target of reducing air traffic-related CO2 emissions and fuel burn by 10% on average per aircraft by 2020. But for NATS, it's not all about emissions. We absolutely recognise that noise is a key issue around the airports where we offer a control service, and we want to work with our airline and airport colleagues to identify how we address that. So my speech is really about what can air traffic do to mitigate noise. And what I'm going to talk about is two things. The things we're doing at the moment, the current activities, and the things we're doing now to inform how we change the situation, how we manage noise better in the future. So, there was a lot of talk yesterday about the Sustainable Aviation Group and the noise roadmap that it published this year. I'm really proud to be the sponsor of the noise roadmap in sustainable aviation, and I have to say I didn't do all the work. We had a fabulous team, including British Airways and Rolls-Royce and a group of airports in the UK that came together to set out what the future of noise in and around UK airports is going to be. So there was some talk about that yesterday. I'm not going to go into that, but what I do want to highlight to you, and I'd encourage you if you're interested to have a look at the document. This for me was a core part of NAT's contribution to the Sustainable Aviation Noise Roadmap. It was really a way of portraying, forgive me if the translation doesn't work, a shopping list for airports, a shopping list for communities and airlines in terms of what are the operational opportunities. So, yeah, it's about identifying what are the best practices. So, steeper approaches, we've heard a lot about that, and DFS and DLR are doing some excellent work in steeper approaches that we'd like to learn more about. But then there's things like, as you heard in the last discussion, displaced thresholds, delayed landing gear deployment, continuous descent, low power, low climb, and continuous climbs. So there's a lot of opportunities there. Now, will they all be deployable at all airports? No, because there are airspace constraints and operational constraints that means some airports won't be able to deploy all of these things. But actually, what we set out in the Sustainable Aviation Roadmap was these are the opportunities actually for the airports to decide and the airlines to decide which of these they want to deploy in order to mitigate the noise around their airfield. Talk a little bit about continuous descent. We've heard about continuous descent in the last day. So we've been running continuous descents. It's kind of in the UK, the way we run continuous descent is it's almost a pseudo contract between the pilot and the controller. The controller gives distance of run information. The pilot then he or she will plan their descent in order to reduce level segments, reducing fuel burn. So that's good for our CO2 target, but also reducing noise between 1 and 5 decibels. But actually, that's the concept. But in NATS, we're very data focused. So in order to set targets on our operational units, in the UK, we developed a specific tool that analyzes the arrival and departure profiles in order to identify where the level segments are occurring, where the increased noise is occurring, and then to drive the units potentially to set themselves targets and improve on that process. I'll show you some of the data that we have in the tool in a minute. But when we first deployed this flight profile monitor, we did a trial with the airlines at Edinburgh Airport in Scotland. And actually, it was quite informative because some of the airlines weren't really, when we started, weren't completely aware of their actual CDA performance. In fact, there were two particular airlines that were operating exactly the same aircraft types, but had something like a 20% or more difference in terms of their operational performance. Now, it turned out that those two airlines talking together and seeing the data identified that there were some standard operating procedures that one airline had that actually in some cases precluded the use of continuous descent. So at the same time as we did this trial, we improved the radar service at Edinburgh Airport, but we did see a 20% improvement in continuous descent approaches, worth in terms of fuel burn to the airlines something like £104,000, so 130,000 euros, and reduced community exposure to noise. So that was us trying to prove the concept that data can drive operational behaviours. The data we have in this flight profile monitor is quite detailed. So you can see here, actually, we can break the data down in terms of performance down to the air traffic control watch. So air traffic control now will understand, watch by watch, what is the performance? A bit like the example I gave earlier of the airlines speaking to each other about their performance. Now the watches can talk. The best watch can talk to the least performing watch and understand what things they're doing to improve that. But we also need to give them information about where these level offs, where the non-compliance with CDA is occurring. And you'll see on the right-hand side of this chart, we can actually plot where the level offs, where the non-compliance is happening, and then back onto the left-hand side of the chart, you can see actually we can identify exactly in terms of the altitude where the level segments are occurring. And this can sometimes be for airspace reasons. So actually, you see the example there, that will drive our controllers and our airspace designers to look at two particular points on this approach to identify whether there's something we've done in terms of designing the airspace and the procedures that is actually causing these level offs. So this is an example of some of the data that we actually were able in the trial to break down to individual airlines, and we picked out BA Cityflyer and Jet2 there as two airlines that actually had quite variable performance. Loganair, a small carrier that had other issues in terms of the aircraft types that they use in terms of doing continuous descent. But you can see by giving the airlines this information, we can bring everybody up to a new level of performance. So we've moved on now. We've completed the trial of this flight profile monitor and CDA at Edinburgh. We're now working with EasyJet at Bristol Airport in the south of the UK. And you can see here, we've already, just in the first few months, started to improve the performance, or EasyJet have started to improve their performance, really just based on understanding when they're doing CDA, when they're not doing CDA, and how they can improve their performance on a day-to-day basis. They're saving at the moment something between 50 and 100,000 pounds a year just by improving their continuous descent approach. So what are the trends? Well, if we look back over the last 6 or so years, we've seen an improvement of around 15% in continuous descent approach. And for the London flight information region, for the London airports, we've seen an improvement on average between from 60 to 75% CDA improvement. So where are we going next? So I'll refer back again to the Sustainable Aviation Noise Roadmap. In the roadmap, we've set out what we'd like to do in terms of improving CDA performance as a key opportunity to further mitigate noise across all the airports in the UK. So we are working with our airport and airline way in continuous descent, which is typically at London airports from around 6,000 or 7,000 feet. We're currently performing at between 85 and 90%. There's more to do there. There's certain carriers that are maybe less familiar with the distance to run information that we give and how they can use that to achieve CDA. But this action plan will be there to try and target those airlines and give them increased levels of, one, data, and two, information about CDA. So that's kind of an indication of what we're doing at the moment, and continuous descent approach is the cornerstone of our noise mitigation opportunities on arrival. But I think there's other things we can do, and we're working with our airport and airline partners in the UK to try and identify what we might be able to do. One example of that is an early morning arrivals noise trial. It's really focusing on the concept of giving communities predictable, a really important word, predictable respite from noise impacts. Where did that come from? Well, actually, it came from government in the UK. The Secretary of State, the then Secretary of State, Teresa Villiers, said to BAA, who run Heathrow Airport, and HACAN, the local the Heathrow Anti-Noise Group, and the Aviation Environment Federation, the umbrella group for aviation NGOs in the UK. You need to find some common ground about noise and how you manage noise at Heathrow, and it was a really good challenge. As part of that, we operate the air traffic service at Heathrow, and Heathrow said to us, we need you in the room to have this conversation, as well as we need some of our airlines. And in this case, it was actually Dean from British Airways who took part in that. And we sat down and we spoke with the community groups and tried to establish, well, what do we do here? What can we do that jointly we can both commit to finding a way forward, finding a new relationship in terms of how we manage noise. As a result of that, we talked about noise metrics and the way you measure noise, but importantly, we also talked about what trials can we do to try and improve the situation. So Nat ran some workshops looking at what the operational opportunities and possibilities were with British Airways and BAA, and two key concepts emerged. One I will talk about today, and one I'm not going to talk about today. Actually, we talked about, could we use the sort of technology you've seen talked about this morning, precision navigation, to alternate noise on departure routes? And I'm not going to talk about that today because we haven't run that trial. That trial is planned. But what I will talk today about is an early morning arrivals trial. So nighttime and people's sleep is very important. The predominant runway direction at Heathrow means that aircraft arriving in the early morning period between 4:30 in the morning and 6 tend to arrive over central London. Obviously, a very sensitive time of day. So we spoke with HACAN, and we devised jointly a trial which sought to try and minimise or at least manage the noise from these early morning arrivals. And this is broadly speaking, what we did. So we have there was a rule at Heathrow: you can't join the instrument landing or the extended centre line inside 10 nautical miles at night. That's for noise mitigation reasons. So we established the concept that could we establish no-fly zones over central London. 1 week we will avoid flying through particular boxes, and in that example, week 1 we would avoid these inner boxes. Week 2 we would avoid these outer boxes. How would that work for the communities? Would they recognise that they were getting this respite? So this was not a technology-based solution. This was a working solution. Actually, on the radar maps that our controllers saw, we had a temporary operating instruction for the period of the trial. They actually saw boxes that said, "Don't fly in here," each morning between 4:30 and 6. And how did the trial go? Well, actually, across the period of the trial, this is an example of the inner boxes being active, and you can see the controllers are obviously routing the aircraft. There's about 16, 17 aircraft in this very early morning period, obviously routing the aircraft to avoid these boxes and giving these people in London predictable respite from noise. The performance throughout the trial, this is an example of the boxes. We have boxes at both ends. The performance of the trial, something like in the mid-90s% of adherence. So the boxes, when they were active, were avoided something like 95% of the time. Why was there 5% non-compliance? Well, actually, sometimes there's weather avoidance. There's sometimes emergency flights that need to go direct, and they would contravene the box. But at other times, there were issues where actually an aircraft just clipped the box. This is a British Airways 777 actually that just clipped the box by maybe 100 meters, but it was non-compliant. It doesn't work all the time. We have had a few examples where we clipped the box and just went inside it. So, but performance overall, I think for an operational system, 95% performance is pretty good. So where are we now, and where are we going next with this? Well, the trial's complete. It started on the 5th of November last year and ended at the end of March 2013 this year. We had a number of community consultation meetings throughout the trial and after the trial, and Heathrow have prepared a report which you can see on their website. So this isn't the end of the discussion. We continue to work with Icana on what are the next steps. But I would say, and I think we kind of suspected that this might happen when we went into the trial. There's sometimes when you do things like this, unintended consequences. If you establish no-fly zones, the aeroplanes approaching Heathrow will have to go somewhere. And actually, what we did find in consultation with the communities, in terms of complaints that we received, there were some winners. There were some people who actually appreciated the fact that they could guarantee on a particular week that they would not be overflown by aircraft in the early morning period. But there was a concentration of arrivals as a result of the no-fly zones. There was a concentration in a couple of locations in the UK, in London. And actually what we took away from the trial was, there were always going to be winners and losers in this. But I think it was good to work with the communities to identify what the opportunities were, and we'll see what we can do next. And as I mentioned briefly, we have another trial that we will be running at Heathrow on departures, and maybe I can talk about that at another event like this. So we don't just work with Heathrow. Gatwick have also done similar activity, looking at this is a density plot of nighttime arrivals at Gatwick Airport, which is just to the east of Heathrow. Looking at these plots, the airport actually identified two key areas where they wanted to try and provide some nighttime noise respite. They established these areas as the places that they thought were particularly sensitive, consulted with the community, had extensive consultation, and then established some similar no-fly zones. So not boxes in this case, they're actually fillets of airspace. And you can see there, this was the fillet that was seeking to avoid Royal Tunbridge Wells. There's one aircraft going through it. We're investigating why it breached that no-fly zone. But typically you can see here that we were able to route the aircraft to avoid the no-fly zone. Then we established a no-fly zone inside the route swathe there to try and avoid a particular area of community sensitivity around the nighttime period. So some success there. We actually didn't get any complaints about a concentration of noise in this trial, but it's finished recently, and we're still looking at the results with Gatwick Airport. And we've heard a lot about precision navigation. Stansted Airport in the UK, we're trialling some precision navigation techniques to really try and focus the noise down over a particular area. You can see there the approaches to Stansted Airport, the departures have quite a wide variation, quite a wide swathe of tracks across the ground. Actually, in putting precision navigation in, we were able to avoid noise over quite a large part of Uttlesfield District Council, and really concentrate the noise down to reduce the impact on a very large part of the community. And this is the other direction. Again, you can see we were able with precision navigation to really narrow down the impacts of noise. So what can air traffic do to manage and mitigate aircraft noise? Well, I hope I've given you some examples of things we're doing in the UK that we believe have opportunities to manage and mitigate aircraft noise. Are they perfect? No, but I think it is a big step to work very closely with the communities to identify what their needs and wants are. So in summary, in the UK, we're looking very closely about continuous descent approach. What can we do? We have good performance at many of our airports, but are there further improvements possible? Really key there, using the data to drive setting targets. Community engagement is definitely going to be still on the agenda for NATS, the airports and the airlines, because those are where we get the ideas to drive the innovative trials that we're running. Of course, working closely with airports and airlines. And it's important, actually, when we do these trials, to collect feedback and act on that feedback. I mean, the communities are keen to give us feedback on the noise performance of the airports in the UK, but it's actually, really accurately collecting that feedback and acting on it. And for me, the Sustainable Aviation Noise Roadmap is a template, it's a shopping list, and we're working with our airports, we're working with the airlines to identify what the opportunities are through that noise roadmap. Thank you.
Thank you very much, Mr. Jopson. So, damit wir ein kleines bisschen Zeit aufholen.
Well, we need to catch up a little bit on time. Therefore, we only have the chance for 1 or 2 questions. We're a little bit behind. We'll also have Mr. Jopson in the Q&A session this afternoon. So if you have any additional questions, you also have the chance this afternoon to raise those questions. So there is a question in the back and one here in the middle section of the room. Please wait for the microphone.
Just interested in your metric of avoiding level segments. Is that really a good metric to look at CDO? Because a level segment can be very good from an energy management point of view. If you have to use speed brakes in order to really fly a continuous descent approach, this is neither noise beneficial nor energy beneficial. So my question is, isn't it sometimes even good to have a level segment in CDO operations?
Yes, good. That's a good question. So you're right to flag that. Some years ago now, we developed a continuous descent approach code of practice with actually many of the members of Sustainable Aviation and the UK government. And in that, we recognised that some aircraft, in particular the aerodynamically slippery aircraft, tend to need a level of energy management in the approach. So actually, our flight profile monitor tool allows us to tailor what level segments it picks up and what it doesn't. At the moment, we allow for something like 2.5 nautical mile level segment for energy management on the approach. So we can tailor the tool to identify whether there's level segments of any length or whether they're compliant because they're actually the aircraft is doing an energy management level segment.
Okay, vielen Dank. Dann hier in der Mitte, ich glaube von der VC.
Okay, we have a question over here from the middle. I believe that's Mr. Brown again.
Just 2 questions. On your maps, the tracks, have they been derived by radar vectoring, or have any of them been constituted by aircraft navigation performance tools? And question 2, what type of meteorological term does justify or constitute the operation of weather avoidance? Thank you.
Okay, so the first question was around the tracks. Those are all radar derived tracks on those plots. They're from our radar systems. In terms of weather avoidance, typically the weather avoidance that would mean that we would infringe one of the boxes in the trial would be thunderstorm activity or potentially strong winds or things like that, particular weather events like that, which we would seek to direct the aircraft around rather than through, and sometimes that meant that the aircraft would go through the no-fly boxes.
Okay, letzte Frage dort hinten noch.
Okay, last question in the back.
On one slide, you wrote that you reduce noise. What would you say, do you reduce noise or do you focus or concentrate noise on special areas? What's the bias between the two descriptions of what you do?
That's a good question. So the UK government's perspective on noise management is, and their policy is to reduce or to reduce noise and actually to concentrate noise. Now, we recognise that in particular with PRNAV routes, that has an issue for the people who are underneath the concentrated track. That's a really big issue for those. And actually what we're looking at now is a large airspace change that we're consulting on at the moment over the south of England. We've got some details about our thinking on this, is can you deploy those precision navigation routes but actually alternate them? So that there's not one community that gets all the noise all of the time. So we're looking at that. There are operational challenges around that in terms of the flight management systems on aircraft. There's adaptation that would need to happen for our systems so that we can accept the additional routes. But we're exploring whether there's a possibility that within concentration, you can alternate the concentration to give people predictable respite from that noise. We're working very hard on that, and we hope to be trialling some of those concepts in the near future.